Okay, so here we are back with continuing with these notes. And this is what your graph should look like for y equals -3. Every one of those points goes over a certain amount, but then drops down to -3. I kind of think about it also, y being the height. The y equals -3 means the entire line, the whole height of it, came down. Okay. Now, one thing I want you to watch out for is that y equals -3 is very different than y equals -3x. Okay, these are not the same. If this were y equals -3x, then I would have plugged my x value in here, and the first y would have been 6, and the second would have been 3, and the third would have been 0, and it would have been very different. So just watch the difference between these two. If there's no x in it, that's when it's a horizontal line. If we look at the next page, we see an equation that looks kind of similar, except it's an x equals a number. So it's, again, a little bit weird compared to what we were looking at before, but it's going to be that x equals a number, and that is going to give us a vertical line. So if we have x equals 4, again, if we want to do a chart, this time our rule says that we don't get to pick our x's. No matter what, our x has to be 4. So we have to fill in 4 here. Now we can put whatever we want over here in the y, because our rule doesn't tell us anything at all about y. We could put 87 in y, and it would be 487. So if I go ahead and graph this, every one of these points goes over to 4, and then either stays there for 4, 0, or goes up for 4, 1, up for 4, 2. So you can see that we're creating this vertical line. So my hope is that you get comfortable with these enough that when you see x equals 4, you know it's a vertical line going through 4. When you see y equals -3, you know it's a horizontal line going through -3. But if you forget where they're supposed to be, you can recreate that by making a little chart. Okay, so excuse me. On page 12 at the bottom, there are a couple paragraphs there, which I would like you to read on your own. But the general idea of those is that every graph that we've done so far has been a linear equation. It's made a straight line. Well, we can use the plotting point method for other kinds of equations too. And there are two other kinds of equations that we're going to talk about. We're going to talk about quadratic equations and absolute value equations. Okay, so quadratic equations have an x squared in them. So on page 13, you see y equals x squared plus 3. Linear would be y equals x plus 3. Because we have an x squared, this is what we call a quadratic equation. And usually, if we're in class and I say, what shape does this make? At least a couple people remember that they might say, oh, it makes that U shape, which it does, and it's called a parabola. And it either looks like this or like this, okay? The way it opens depends actually on whether this x squared is a positive or negative term. We don't get into that now. If you take Math 120 next semester or over the summer, you'll get into that there. Okay, but we have this quadratic. So the nice thing about this plotting points method where we do our chart is that we really don't need to know a lot about this equation before we do it. We just plug in for x and we get out y. I do want you to know that you're expecting a parabola though, because it's x squared. So for these, I will give you your x value. For a linear equation, it's just going on the same way forever, so it really doesn't matter if we graph this part or this part or this part, right? With a parabola, we can graph any of them, but if we ended up just graphing this, it doesn't really tell us a lot about the parabola. It's kind of boring. We want to make sure we get this turning point in there. So that's why I will give you x values for these. Now in this case, we can still use our normal -2 up to +2. Here's our y, and then again we'll have our point here. Okay, so we're going to plug in our values of x as we always have. So the thing we want to be careful of is squaring a negative number. We talked about this earlier in the year. But if we put in our calculator -2 squared, that's going to give us a very different answer than -2 squared. Okay, this is what we want. We want -2 times -2, which is going to be +4. This one, it's telling it to square 2, which is 4, and then make it negative, which is not what we want. So if you are squaring a negative number, make sure that it is in parentheses. So we're going to have -2 squared plus 3. Here we would have -1 squared plus 3. 0 squared plus 3. 1 squared plus 3. And 2 squared plus 3. So this is going to be +4. 4 plus 3 is 7. +1. 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 7. So here are my points. Now, if you remember, we kept talking last time about how we had a consistent pattern. If this went up by 1, this went down by 3. In this case, though, the next step isn't the same. We go up by 1, now we only go down by 1. We go up by 1, we go up by 1. We go up by 1, we go up by 3. That's what gives it a curve, okay? The slope, if you think about how slanted it is different here than here. That goes along with this pattern, so that's why it's a curve. Now, when we graph quadratic equations, what we are not doing is we're not just connecting the dots. So let's graph the points first, and then I'll show you what I mean. So we have -2, 7, -1, 4, 0, 3, 1, 4, 2, 7. Okay, so first of all, you know that because it's a quadratic equation, it should make this parabola, this U shape. If it comes down here and then kind of makes an S down here, that is a huge red flag that you did this squaring of negatives wrong. Okay, you notice that it's symmetrical. I should be able to fold it wherever this point is. In this case, it's on the y-axis, but let's say it were over here. You would fold it wherever that point is and it would touch, so you can see this symmetry. Then we're not going to connect it with connect the dots so it has a bunch of little corners. We're going to do our best to draw in a smooth U-shaped curve. Now, the nice thing for you guys in a way, excuse me, is that when you do a test, you're doing it on Lumen, so you don't have to worry about doing it by hand, but you still need to know how to do that. And then again, we'll label it y equals x squared plus 3. That's my quadratic equation. Okay, so the next page, page 14, has an absolute value equation. Okay, so when we are figuring out absolute value, there is the absolute value sign. And if you remember, that means the distance from 0. So what that really means is how far away from 0 is this number? Well, a distance always has to be positive. So if I have, let's pretend I have the absolute value of -3. Well, -3 is right here on a number line. How far is that from 0? It's 1, 2, 3 hops. So the absolute value of that is 3. The absolute value is distance. It's not direction. I can't ask you to go walk -3 feet down the hall. It's just going to be 3 for the distance. So whether I'm at +3 or -3, each of those is 3 hops away from 0. So because distance always has to be positive, once we have one number inside the absolute value, it's going to become positive. We have to just get down to one number first, though. So if I have this y equals absolute value of 2x plus 1, I'm going to plug in my values of x. Now, when you're writing your absolute value, make sure it's big. If you write it too small, you're going to think you have 12x plus 11. Okay, make your absolute value signs large enough to realize they're not ones. So if I am going to have, again, x being -2, -1, 0, 1, and 2, and y equals absolute value of 2x plus 1. Let's do this one together. So you're going to have 2 times -2 plus 1 in the absolute value. So we do what's inside at first using order of operations. So -4 plus 1. -4 plus 1 is -3. The absolute value of -3 is just plain 3. Okay, let's do one more. -1. So absolute value of 2 times -1 plus 1 is -2 plus 1, which is -1. Absolute value of -1 is just plain old 1. So I have 2 points there. Okay, I'm going to have you do the rest of this and graph it on your own. I will tell you that an absolute value equation, think of the V for value, that's the shape that it will make. Okay, again, up or down depends on the positive or negative here. Yours is going to be up. So go ahead and finish this chart and graph it. Okay, this time these are straight lines. So you can use your straight edge to make this one, oops, and then this one. Label it with your equation. Okay, and that's going to be the last one. So you can pause the video, you can go ahead and finish that chart, and then you can look back and check your answer. Okay, so if you got this done, you can see here, we can see where the y values are going down and then come back up. So you can see that's going to make that V. And we'll take a look at that point there in just a second. So let's go ahead and graph what we have. So we have -2, 3, -1, 1, 0, 1, 1, 3, and 2, 5. First of all, you can see a symmetry again. You can probably imagine that if we did -3 on our chart, we would also get +5 for that symmetry. Now, if I just connect these, I'm going to have a little flat bottom on the V, which I don't want. So the actual turning point is going to be somewhere here where x equals -1/2. So let's do that part together, right? You can see that it goes down to 1. It's going to go down somewhere else right here. So if I then said x was -1/2 for x, then y is going to be absolute value of 2 times -1/2 plus 1. 2 times 1/2 is just 1. So 2 times -1/2 is -1. -1 plus 1 is 0. The absolute value of 0 is just 0. So that means my point is if I went over -1/2, it would be 0. So now you can see our whole V there. So we can take our ruler and go ahead and make straight lines with that and make our V shape, and then we will label it y equals the absolute value of 2x plus 1. So you can see that V shape, again, symmetry. So you should know when you look at an equation, is it a linear equation and it's going to make a straight line? Is it a quadratic equation? It's going to make a parabola? Or is it an absolute value equation and it's going to make a V? But anyway, out of those ways, you can just plug in for x, get out what you need for y. All right, that's the end of our Chapter 5 notes. So go ahead and start working on the homework, the review quiz, and tell me if you need any help. Thank you.